So, hello guys. Basically, here I'm gonna explain what is a polymer and what does mer mean and what does substantial mean, why do we have this shape, what are these exactly, and what does monomer mean and what the fuck is that basically. So, bully and mer, it comes from the the Greek words. Bully means many, mers means unit. So, if we look at this, and we will call it a polymer, which means we have many units of a certain compound, which is this one here. Okay, so this is a polymer. It's a many repeated units of a certain mixture. Okay, see, this is a whole unit. We have also from here, from here, from here, blah 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 blah. Anyway, if we want to think about the properties of the polymer in general, we need to know the chains and the bonding. And here it's covalent bond, and the chain is 1D. And if we go back to the slides, the things that we studied in the first semester, we will know what are the properties of covalent and what are the properties of the 1D chain. Okay, so we will have two kinds of polymers. The one that has the same combination, the same unit, repeated unit, and the one who is not in the same repeating unit. It's basically a different structure, such as PVC. Wait, let me write here, such as PVC. Go Google what is the chemical structure for PVC. You'll see it. Here we are still talking about polyethylene. If you saw this weird looking shape and the slides of you and you want to understand it, why is it like this? So basically we have to understand what does the covalent bonding look like. Okay, this is the polyethylene, as we said, a centered cell with the carbon and 4 hydrogens, which is, this is a unit, this is a unit, this is a unit, which is a mer, polymer. Anyway, this is from the top if we look at it from the top, and this is if we look at it from the side. And this is the Van der Waals bonding for the same covalent bond we are talking about. If we want to understand what is this exactly, we have to understand that the centered carbon unit, it rotates every time by 109 degree. So basically, if we start like this, it will rotate 100 degree. Okay, it rotated 100 degree. It either has two options. It either rotate from this side or this side. So it rotated from this side. Then it either has rotation from this side or this side, and etc. And this, since we have a lot of carbon and this structure, it will rotate many times in repeating rotation of 109 degree. That's why we have the coil shape, the coil-like shape here for the polymers, the geometry itself. See, the rotations along the chain gives the polymer molecules a loosely coiled string-like shape. Why? Because it's 109 degree, and this is more it's a better diagram than the one I draw. We have the carbon which is bonded with another carbon. The other one, it will rotate 100 degree, and the other one will rotate 109 degree, 109 degree, 109 degree, and so on, and we will have such thing. So now we need to be similar with the this word, monomer. What does monomer mean? Okay, mono mean one, and mer means different or single. So basically, monomer mean a small unreacted single molecules. Mono, a small unreacted single molecules. Okay, if we look at these, don't mind that sound. If we look at these different, this is for ethylene. Okay, this one is different than this one. This one is stable. Why? Because the carbon in the middle, it has both centered covalent bonding with each other. This one, it has no bond, and this one has no bond. It needs another carbon, therefore the carbon needs another hydrogen, and so on. That need a whole processing, a whole different structure, a whole different properties, a whole different materials. It will, if we include like carbon here and hydrogen here, this will be polyethylene. It will not be ethylene anymore. So this is the monomer. This is a monomer for ethylene. Sorry, yes, this is a monomer for ethylene, and this is a mer for ethylene. A monomer, it's a whole unit, like a whole stable unit for the same element or the same mixture, which is this one. Here we have ethylene. So this is a monomer, and this is a mer. Okay, did you get it, guys? This is a mer because it's not stable. It needs more carbon, more hydrogen, whatever. So we call this a mer. We call this a monomer because it's stable. It's unreacted. It doesn't need to react. This one will react. Okay. So if we want to take a deeper look into the same thing, if we have a monomer plus a monomer, okay, let's look at this one. How many bonding we have for hydrogen? We have here 4 and 4, and sorry, 2 2, which is 4, and 2 2, which is also 4. 4 plus 4, it's 8. Here we have 8. This is polyethylene structure. 8 covalent bonding for hydrogen. Okay, how many covalent bonding we have for carbon? We have here, it's 4. How about this one? We have 3. Okay, this is a problem. So why is it a problem? Because we have a one missing bond that is not reacted. That's why we wrote it like this. It's not reacted. So this is a polyethylene with one mer in it. It's not monomer. It is one polyethylene, because a polyethylene, as we mentioned, it's a repeated unit of a monomer. Okay, so we have 2 monomers and 1 mer. I hope you get it. So this is a monomer and this is a monomer. Why? Because it does not need to react. It is unreacted. It's stable. That's it. So when we mixed it together, we had an extra covalent bonding, which is presented like this one here. Therefore, it is a mer, because a mer, it's a reacted unit, or a unit that wants to react.